Here's a short little tutorial on how to do some very useful stuff on your calculator, especially particularly with complex numbers. So to start, we're going to want to make sure we can use complex numbers. So if you press mode here and then go down to this row, it might be in real by default. We want to set it to a plus bi or real plus real to the theta I. This will just allow us to actually use complex numbers. So real straightforward. If you want to press I, you do second period and it makes an I show up. I is I. We can do like 5 minus 3i, and it'll save that as like a number. If we want to save this to a variable, you can use the store button. So you could say like this, store it to x, or you could, I don't know, store it to alpha a, and then it's stored to a. And then if you want to multiply two complex numbers, you could say 9 minus 5i, make sure they're in parentheses, times 4 minus, or 4 plus 6i, and it'll do that for you. So now, say for example, you had, and with this you can kind of do whatever you want. It just works. It'll do all the simplification for you. So let's say we had a resistor and a capacitor and an inductor in parallel, and we wanted to find their equivalent resistance. So what you can do is you can make a nice fraction. Alpha y equals will bring up this menu, and you can press enter, and it'll make a fraction. And so we can say 1 over, and then let's say the resistor was 60 ohms. The inductor was, after we turned it into impedance, it was like J25. So over 1 plus second J25 plus alpha y equals 1 over, let's say the capacitor is like negative J, oh, I did the wrong button, negative J6. So you can do this. This looks like a complicated expression. You would be sad if you had to do this by hand. You press enter, and it does all that for you. Oh no, it spit out a fraction. You can say alpha y equals, go down to the bottom here, that f to d means fraction to decimal, press enter, and there. That would be your equivalent impedance for this resistor, inductor, and capacitor in parallel. And it just like lets you do things like that. If I wanted to divide, I don't know, let's say our voltage was 50 e to the j 60 degrees or something. You could say 50 e, if you do second ln, it brings up this e. You can say e, j, and then you can only input, so if you look here, there's radian and degree mode. This kind of thing will only take radians as its input. So 60 degrees would be pi over 3. So 50 e to the I pi over 3. This is what you'd expect from that. If we want it to stay in that other form that we like more, we can set, instead of a plus bi, we can set it to real to the theta I form, right? And then if we do this, it'll kind of stay in that form. And here, I'm in radian mode, so it'll say radians there. But if you set it to degree mode, it will actually convert this for you. So if I say 50e, it'll convert it to 60. Having it in degree mode is really weird because it'll give it in degrees at the output. But if I said 50e to the 60i here, then it thinks that I'm putting this in radians, and it'll give me something really weird. So you gotta like be careful if you're doing degree or radian. But other than that, it works kind of as expected. And then the most useful part of this by far is if you have your number in a plus bi form, you can just kind of put it here, and if you're in real to the theta I form and you just press enter, it'll convert it for you. So again, before we found this equivalent impedance and it was this scary number, we can just press enter and it'll put it in that real to the imaginary form. So if I then, I'm going to leave it in radian, I'm going to put it back to radian form in case it like messes up on me, because if I put this back in, then it'll think this is 82 radians, and that's bad. So it's good to like do your intermediate calculations in radians, even if your final answer is going to be in degrees. So if I have this is my impedance, and this is my, power source. You can say like, okay, I take this, and then I divide it. You have to put a parenthesis here. This is very important, or else it'll divide by 7 and then multiply by e. But you can do this, and it would like divide them for you. And similarly, we could do our 50, if you want to just put it indirectly, you could say 50e to the I pi over 3, and then divide this by that number we got earlier, which was this. And even though this is like really long and scary, and oh no, we're dividing e to the j theta by a plus bi form, it will do it all perfectly fine and get you the same answer. So mess around with this a bit if you want. It's really useful to be able to do this quickly. It lets you save a lot of time on quizzes. It lets you check your answers, so on and so forth. Yeah, and if you want to change back, you could switch it back to a plus bi form, press enter again, and it'll put it out. This lets you skip a lot of steps. I think it's really useful. I used it a lot when I was taking this class. Yeah. So if you do this on a quiz, I would recommend saying that you did, because you might like miss some partial credit if you mess it up. So just like, this is a good tool. Make sure you use it wisely. Yeah.